Hello again, it's Phil Story, a network detective from Australia. This is number 5 in our Using NetData Lite series, and this time we're going to look at the packet timing chart. And in fact, this is the first time we're going to look at actual packets. Just a reminder about what NetData is about. NetData is about helping the analyst to discover what's the underlying cause of performance or problems visually. So it's about visualizing IT performance. And the packet timing chart, this visualization, really comes to the fore. These are the NetData charts and tables, and today it's all about the packet timing chart and packets. So as usual, we're going to be looking at using the format button, we're going to be zooming in using the back button, we're going to be right clicking on things, we're going to hover the cursor on things, we're going to look at using pop-ups to get help, and we're going to use our favorite Alt keys, including now we're going to Alt, click and drag to measure time. This time I'm going to use this PCAP file that I got from PacketVlad. I'll put the link in the description to his blog. If you recall, this was the teaser from the very first video. So NetData is doing its thing. Now, because it's a relatively small capture and only got basically one client and one server, NetData decides to pop everything up. So I'm going to get rid of them. Events and warnings are sort of telling us the answer already. I'll get rid of that. There's no transactions for the performance chart because this is trace wrangled. Here's our packet timing chart, and this is the flow chart that will come next. Just while I'm here, a reminder about the order button, and if we order by address in this case, we can make our chart a bit neater. But we can tell from the colours that there are packet losses or retransmissions up to 12%. So let's look at the packet timing chart down here. At first blush, if you've never seen this before, you're probably thinking, what's going on? But let me tell you, if you know how to interpret this chart, you can tell from right here what the problem is, or at least what's happening. So let's get down to it, how to interpret these charts. And it's all about size, colour, shape and location. So we notice that there's 3 rows. Row 2 is really just a blank filler row, and it's separating client packets appear along row 1 and server packets appear along row 3 in this case. Different packet shapes and colours mean different things. A black square is a normal data packet. The height of a packet in the band tells us the size of the packet. So if I hover on there, Alt Z, and what we can see, the size of this one is 1028, and the size of this one is 400. So 400 is down here, 1000 bytes is there, and up the top, 1460. So, and we can tell immediately, if a packet is along the top, it's a full-sized one. Alt R. Now what do these shapes and colours mean? Well, the best way to have a look at that is to see the legend over here. And we've seen already that if we hover on the legend, it'll point out where those things are on the chart. Another tip, if a packet type is in the legend, then it must be on the chart somewhere. So blue diamonds, they're labelled as non-data, but they're basically normal ACKs. There's a bunch of those. Black squares are normal data packets. SYN flags, there's 2 right at the beginning where you'd expect them, a SYN and a SYN-ACK. Purple squares are retransmitted data, and there's a few of those on the page. So purple is a visual cue to us, a very strong visual cue, that they're retransmissions. Now selective ACKs are purple diamonds, there's some of those. Red packets indicate that they followed a gap. A red square would mean that there was a missing packet before that data packet, and in this case there was a missing data packet before this ACK. Now green is where a packet came along and filled in that gap. Just looking for red and green on the chart, we can see that there was missing packets, so actually missing, they weren't in the capture, and then a green one is a retransmission that filled in the gap. That's different to a purple one that is a retransmission of a black one that we'd already seen. Now here, interestingly, a quite rare thing is an ICMP, destination unreachable, and they're there in the middle, and they're appearing as a pink asterisk here. Pink squares or red squares, they're very useful because what they indicate, a packet that we saw but we know, or the receiving side didn't see. There's a few of those too. So NetData tries to make things that are interesting and that we should look at jump out of the page. And I don't think there's any doubt that what's jumping out of this page is in this area here. So we can zoom in. So we've already seen these were full-size packets, but they didn't get to the other side. And here we have these loops. So these packets were retransmitted. So purple is a retransmission, and these packets are retransmitted versions of the data that was in those original ones. And an interesting observation, Alt-Z. We've already said they've got a payload of 1460, and over here, Alt-Z, we have a payload of 1310, and one down here, 150, 1310 plus 150, 1460. Down here are some selective ACKs. Hover on that, Alt-Z, and we can see left, right, left, right. It's got two left-right edges in that selective ACK pack. Let's zoom into even closer. Now it's very clear. So there were 4 full-size data packets. They did not get through to the other side. They were followed by 804 byte packet that did get through to the other side. We see this, the data in this first packet was retransmitted as a big one and a little one. Now interestingly, these little ones that were retransmitted, they've got a red square, so they also went missing. So this is a different mechanism now. So we're looking at 2 mechanisms. One was that full-size packets don't get through, and another one is that for whatever reason, small packets aren't getting through either. Now what's this little asterisk down here? It was a destination unreachable. So hover, Alt-Z locks on, and just while we're here we'll see that these are in fact the same. So what have we got? It's ICMP, I can only handle 1350, you'd better fragment. So the sender got the message, he sent 4 full-size packets, got the message, got to chop them up into 1350, and decided to chop them up into 1310 and 150. So what sort of questions have we got here? Well, how long did it take for this ICMP to come back? Well, we've got a timescale along the top, but a way to measure times on these charts, and in fact performance charts too, is hover, Alt, click, drag. You can let go of the Alt key. And when NetData gets close to a packet, it puts a circle around it to indicate that it's locked on. Now we've got to look at the top right. I can lock that on actually with an Alt-Z, and here we get the time interval, 1.14 milliseconds. So that ICMP came back fairly quickly. Alt-R. Before we go and look at the buttons, the other information that's on this chart is we said this is the client row, and this is the client information. So that's the client IP address, the client port. This connection ID is just an internal ID that NetData made up for its database, and we've got the same connection ID, but the server was 1.169 and the server port was 445. So let's look at some buttons. There's the usual copy and save. Addresses, will just toggle names and addresses in that right hand side. There's no addresses here. We press the packets, we get the packets table, and as usual, lots of columns. You can turn things on and off. We've got the flags here. Because we pressed the button when we were looking at this particular small timescale, that's where the packet table starts, and we can see the 5 data packets, some retransmissions and our ICMPs, and there's some data about the ICMP. Sometimes it's quite handy to look in the content or comments, but otherwise it's pretty rare to actually have to have a look at the packet table. And here we can also see that we have per packet calculated round trip times. What other buttons have we got? What I forgot to do at the beginning in the dialog chart is options, show us round trip times. The vertical line is on the right. So in fact, the client is 30 milliseconds away from where the capture was taken, which is essentially at the server side. Now I won't bother bringing it up, but we can have the frequency distribution histogram of round trip times, gap fill times, and these, which I've never used. The flowchart will pop up the NetData's flowchart, which is the TCP trace equivalent, so that's going to be the next video. One more thing to talk about before we leave this PCAP file is these green diamonds, which were duplicate selective ACKs. So duplicate selective ACKs, what are they? We know that a duplicate ACK is a copy of an ACK, and we know that that's telling us that there must have been a lost packet. The duplicate in duplicate ACK is saying that the ACK was duplicated. But a duplicate SAC is the receiver using the SAC mechanism to inform the sender that it had sent the same data packet twice. Now that's worth a zoom in. Before we do that, so if the left and right edge are below the normally ACKed line, in other words, represent data that's already been ACKed, then we know that this is a duplicate SAC. Here's a data packet, Alt-Z. Here's a retransmission of that same data packet, Alt-Y, Alt-X, Alt-Z. They have different IP IDs, so it's a genuine retransmission. It's not just a duplicate in the PCAP. There's the acknowledgement for that, and also there's the DSAC. Just a useful tidbit in case you've never heard of the term DSAC. Now, just before we leave this capture format, you can have links between data packets and their ACKs, replot. Now that's very handy sometimes to show which ACKs went with which data, and sometimes that can matter. Grey markers is interesting, and that happens when you click it. I don't need to replot. That hides all the sort of normal black packets and only brings to the front the unusual packets. The grey lines we're seeing, they're just for us humans, and they're saying what happened next. So there was this packet, and then the next packet was that one. We'll go back to PacketBombs and drop that in there. I'll fast forward from here. Now, although these are packets that we're looking at, because NetData knows the underlying transactions, it actually plots the transactions as well on these things so that we can tell this was that transaction and it had a lot of data being delivered. This one had a lot of data, and what we can do is right click, plot only this one, and we go back to that view. Now we've got these pink lines. What were they? Links between data packets and their ACKs. This is the only data packet from the client. All those data packets are acknowledging that one. Whereas in this packet flow, there's 133 kilobytes of data in this flow. So the yellow lines are saying that these ACKs are acknowledging those data packets. It's a packet timing chart, but we can tell what the transaction is. We can see what the data packet coming back. And remember the colors. Yellow means it was server time, so the request was there, the first response packet was there. So blue is packet delivery time. Let's call it a day for the packet timing chart. There's my information. Comments below if you're interested, and stay tuned for the next one. And we'll see what Kerry calls TCP trace on steroids, or wizard mode.